This is our assignment 2 video presentation for the July 2025 semester. This is our table of contents for 4 parts. This is our group member, Omar, Silen, Yilin, Chen Sihan, and Chen Jiajiang. In this video, we will explain the basic concepts of differentiation and integration, and explore the applications in survey energy programs. We will present 2 case studies, one on the rate of temperature change and another on calculating the volume of water in a tank. Let's begin with the concept of differentiation.
Differentiation is a mathematical tool that describes how a function changes locally. It also gives us a linear approximation at a specific point. It also tells us how fast something is changing with respect to another value, which is usually time or position. In engineering, differentiation is widely used to measure velocity, acceleration, temperature change, and pressure variation. Okay, now let's take an example of temperature change. Okay, it says, suppose a metal object is heated and its temperature follows the function T equal 100 minus 20 e power negative 0.5 T. We want to find how fast the temperature is increasing at T equal 4 minutes. Okay, now we want how fast the temperature is changing given that T equal 4 minutes. Okay, to solve this, we have first to differentiate the function. So it's gonna be dt over dt equal 10 e power 0.5. And then we substitute T equal 4. So it's gonna be dt over dt equal 10 multiply e to the power of negative 2. And if you put it in the calculator, you will get 0.1353. So we're gonna substitute that in the function. Okay, after we substitute that in the function, we will get 1.353, which if we look at the graph given here also, we see that at that specific point, the temperature is rising at 1.353 degrees Celsius. So you may ask, why is this important? In engineering, this is important for designing systems. Then you tell me what kind of systems, like thermal processors or heat treatment machines, where knowing the exact rate of heating helps maintain safety and performance.
Let's now visualize the problem we just solved. The flow rate is Qt equals 5t, which increases linearly over time. On the graph, time is the horizontal axis and flow rate is on the vertical axis. If we look at the curve from t equals 0 to t equals 4, the area under the curve represents the total water volume that entered the tank. Because the graph forms a triangle, we can use geometry to verify our answer. The base of the triangle is 4 and the height is q, 4 equals 20. So that means the area will be 1/2 times 4 times 20, which equals 40 liters. This confirms our integration result. In engineering, using graphs and integration helps ensure precise control in water systems, plumbing operations, and storage tanks.
Integration is the reverse of differentiation. It helps us calculate the total amount of a changing quantity. For example, if we know the flow rate of water going into a tank, we can use integration to calculate the total volume of water added over time. Let's look at a real example. Suppose the flow rate is given by the function Qt equals to 5t, where Q is in liters per minute and T is in time in minute. We want to know how much water has entered the tank between T equals 0 and T equals to 4 minutes. Okay, here's the solution. First, we set up the definite integral over here. Then we integrate the function. Then we substitute the limits from 0 to 4 into the results, like right here. So the total volume of water that entered the tank in 4 minutes is 40 liters. In engineering, such calculations are essential for designing fluid control systems, pumping mechanisms, and storage tank capacities.
In this volume, we talked about 2 things, differentiation and integration. Mathematics is not just about numbers, it's about solving real problems. through differentiation and integration. We turn change into understanding and complexity into clarity. Differentiation helps us know how fast something is changing. We showed a temperature example to explain this. Integration helps us find the total values. We used a water tank example to show how to calculate total volume. These two tools are very useful in real engineering work. Thank you for watching our video. Here are our references.